Okay, so for the last video for the week, let's compare our recursive algorithms to their equivalent iterative counterpart. So, yung iterative counterpart na tinatawag natin is yung gagamit tayo ng straightforward na for loop. So, let's consider this iterative version ng ating factorial function wherein yun, f starts at 1 and nag-multiply tayo ng I plus 1 sa kanya for I in range n. So this should result to the same result as yung ating recursive factorial kanina. So when we run this, hindi ko pa pala nararan yung original na factorial. So para lang mag-load siya. Okay. So ordering matters. Then, basically, dalawang factorial functions pareho yung result. So, ano yung difference natin? So, of course, papasok dito yung ating algorithm analysis. So, looking at the iterative version, we can say na yung kanyang time complexity ay linear with respect to n. Kasi meron tayong for loop dito that repeats itself for n times. And considering na constant runtime to, so assuming this is O of 1, this for loop should be O of n. And considering na O of 1 din to and O of 1 din to, the whole function is O of n. So comparing this to our recursive version, linear din siya. So walang difference doon. However, yung difference natin dito, yung iterative function natin only has one temporary variable to store the temporary result. So ang kanyang auxiliary space complexity is just O of 1 or constant. So yung ating factorial function on the other hand, meron siyang space complexity na linear din. So pag pinag-compare natin yung iterative at saka yung recursive na factorial function, actually, in general, mas magandang gamitin yung iterative version na lang kasi hindi siya gumagamit ng extra space. So, in other words, recursion actually made it worse. So, ayun. That only means na hindi ba dapat tayo, parang umiwas ba dapat tayo sa recursion because it would take additional memory? Actually, that is not entirely true. Depende din siya sa ating problem or application. So let's consider yung iterative version naman ng ating binary function which prints all n-digit na binary numbers. So dito sa iterative version, gumagamit tayo ng temporary na storage na all wherein doon natin sinostore yung ating mga I-digit binary numbers. So, for example, for the first iteration dito sa list na to, magsa-start si, let's write it down. So, at I equals 0, ang ating T at the start, malalagyan siya ng for all yung laman nito. Madadagdagan siya ng B at saka either 0 or 1. So after I equals 0, ang ating all, ang magiging naman niya is 0 and 1. And then pag I equals 1, ayun pa rin yung result pag I. From I equals 0 to I equals 1. I mean, pag I equals 0, siya yung first iteration. Papasok lang siya dito pagka n equals 1, di ba? N equals 1. So, one digit na binary numbers. Then, for the next iteration 1, ang all natin after this loop, you'll notice na all, laman niya is lahat ng 2-digit na binary numbers. So, notice na yung same principle siya as the one we used earlier sa recursion na kukunin natin lahat ng I-digit na binary numbers. So in this case, pag I equals 1, kukunin natin lahat ng 1-digit na binary numbers and dudugtungan natin ng either 0 or 1. And in this case, nagagawa natin lahat ng I plus 1 na binary numbers. I plus 1 digit na binary numbers. So pagdating natin sa dulo ng loop, which is n minus 1, ang result natin dapat is yung ating n digit na binary numbers, which we can confirm pag nilan natin yung ating algorithm dyan. So all 3 digits, pwede natin palitan to 5, maging lahat ng 5-digit na binary numbers. So same functionality siya dun sa ating recursive na definition. However, looking at the time complexity, so actually meron akong konting explanation dito. But ayun, let's assume na yung pag-append natin sa list is constant and yung pag-append nga sa list ay constant. And something constant done 2 times, constant pa rin. And then, so nagde-depend na lang yung iterations natin doon sa number of contents ni all. Eh kung si all contains, well, pwede naman natin iwan na length ng all for now. But, ayun, looking at this other for loop then to print all the contents, length din ni all yung kailangan natin. And or actually, yung worst case pala dito is len ni t, which is len din ni all. So, medyo interchangeable sila in that sense. So, ayun, ano ba yung length ni all? Ang laman ni all is lahat ng n-digit na binary numbers. So, yung lahat ng n-digit na binary numbers, alam natin is 2 to the n. So, 2 to the n times n, kasi gagawin natin siya n times, worst case. So, yung inner part ng loop is done n length 2 to the n times. And uulitin natin siya for n times. So, n times 2 to the n. So, pareho lang siya dun sa original na recursive na binary. So, ano yung better actually dito? So, looking at yung ating iterative na implementation, we actually use a temporary variable in all or a temporary container. And before the final part ng loop, it would contain 2 to the n minus 1 na elements na hindi naman natin kailangan lahat. Since kailangan lang naman natin i-print lahat ng n digits, hindi naman natin kailangan i-store sa list. So it's completely unnecessary for our application. Pero yon, since nagsusstore ka ng 2 to the n na elements, and each of those elements ay n digits, so that is actually n 2 to the n na space. So because of that, hindi na actually masyadong masama yung space complexity ng ating binary function na O of n squared. So because we are using yung ating program stack, actually, nakatipid tayo ng konti on memory. So yun lang yung gusto nating sabihin with these two examples. So in a way, sa factorial, hindi siya nag-improve. It actually made it worse. And dito naman sa binary, actually, nakakatipid tayo sa memory. So why is that? It's because of what we call backtracking. So essentially, sa ating recursive na function, parang binibuild natin muna yung isang n-digit na number. So kung wala 5 digits. So magre-recursion siya hanggang makabuo siya ng 5-digit na binary number na 00000. And when we say we backtrack, i-undo natin yung huling kinabit. So huling kinabit natin dito is yung 0 sa dulo. So mag-undo lang tayo and papalitan natin siya ng 1. And yun yung ating print. And after naman nun, mag-undo lang tayo ulit and mag-undo ng isa pa, tapos papalitan naman yun ng 1. And then we repeat the same process. Mag-start sa 0, print na yan, and then, ayun. So parang, basically, nagsimula tayo at, or parang nag-recursion muna tayo until makabuo tayo ng isang possible na solution, and then nagba-backtrack tayo, and we just modify our solution partially to get another solution. Kung i-compare natin to sa ating iterative na implementation, kailangan natin i-store lahat ng temporary results natin. So kailangan muna natin i-store lahat ng 3-digit na binary numbers before we get the 4-digit na binary numbers. So of course, pwede naman natin i-modify yung iterative natin na function to also employ some sort of backtracking, pero hindi siya ganun ka straightforward. So yung ating program stack, it allows us to use recursive functions basically use the program stack to make or to utilize yung pagbabacktrack. So in cases na actually yun nga dito sa binary na function natin, we can say na mas readable actually yung code. So kung titignan nyo tong function na iterative, so medyo madaming lines, may dalawang for loop, and so hindi ganun ka straightforward yung gusto niyang gawin. But looking at yung ating iterative version, kung alam mo naman na ang ibig sabihin ng binary na function, it gets yung n minus or yung n digit na binary numbers, alam mo na pag nag-n-1 ka, these are all the n-1 digit na binary numbers. So it's a bit more efficient pag kinode natin. So ito ay 1, 2, 3, 4, 5, 6 lines compared dito sa ating iterative version na 3, 6, 9 or 9 lines plus yung pagpiprint pa natin. So in a way, yung ating paggamit ng recursion actually saves on some space. So ayun, so actually meron tayong in general dalawang cases wherein we want to use yung recursive function. So whenever we want to use or utilize yung pagbabacktrack, yun yung usually natin ginagamit ang recursion. And then another thing is, especially doon sa mga problems nga na kaya nating i-redefine using itself, it makes the code more readable when we actually use recursion. So ayun lang naman. So I guess to summarize the topics we covered for this week, we first have yung recursive functions, they call themselves, and especially useful pag kaya natin i-solve yung isang problem by solving a smaller version of itself. So actually, magagamit natin to next week when we get into divide and conquer. However, ngayon, we talked about yung pagkuha ng time complexity and yung space complexity ng recursive function. So in general, yung pagkuha ng time complexity starts with our recurrence relation na generalize ko here. So yung t of n natin, meron tayong recursive call na meron tayong t of h1 of n, wherein yung h1 of n yung parang modifying function natin. So in the case of binary, yung ating h1 of n, pareho silang n-1. So dalawang n-1, so 2 times t of n-1 yung sa binary. And then yung f of n natin, siya yung nagde-describe ng ating non-recursive function calls and yung other commands ng ating algorithm. Then g of x naman yung runtime natin ng base case, which could be a function of different parameters. Pero usually, what makes a good base case is yung mga base case na O of 1 or constant lang din yung runtime. So we want actually yung g of x dito to be constant, pero to not lose any generalization, dinagay ko na lang is g of x. So ang goal naman natin next is to simplify this para dapat si t of n, hindi siya defined by t of n. Defined dapat siya by a closed form na expression. So we have two ways of doing that. So the first one is the substitution method. wherein we expand the recurrence relation to find the pattern para ma-generalize natin yung equation and substitute a variable. Usually, k yung ginagamit natin. Kasi yung I ginagamit siya as iteration and yung n siya yung total and yung x medyo mukha siyang multiplication. So, k na lang yung gamitin natin. And then, ayun, so since we have a general expression for the recurrence relation, try to find a suitable expression for k na magre-result din sa base case. So for example, dito sa nauna nating example uh, sa factorial, so si t of n, na define natin siya as t of n minus k plus k times c1. So si n minus k, naganap tayo ng value ni k wherein magiging t of 1 yung nasa loob niya, which is yung k equals n minus 1. Para doon sa ating substitution method. Then next sa recursion tree method, para siyang sa substitution method, pero yung pag-expand natin, hindi tayo nagsistick sa equation. We put them on a tree. And ine-expand natin siya per level. Then, similar sa substitution, naghanap tayo ng general expression no total runtime per level ng tree. And then, we also get the depth of the recursion tree, which helps a lot in solving for the expression ng total runtime. Kasi pag pinagsama-sama na natin yung per level, it will help pag alam natin yung depth para pag meron tayong summation or pag naging multiplication siya, production, meron tayong magagamit na boundaries ng ating summation. So, looking back dito kay binary na operation, meron tayong expression of t of n na in terms of a summation. And by knowing the depth, alam natin yung boundaries ng summation and kaya natin siyang i-simplify to yung kanyang final expression na n to the n. So yun ang sa recursion tree method. Now, when getting naman yung ating space complexity, similar siya sa recursion tree method. Since isang path lang naman yung tinitingnan natin, sa recursion tree kasi natin mas nakikita kung nasaan yung deepest na path, which is yung i-consider natin for space complexity. Pero instead of getting the total per level, kailangan lang natin makuha yung parang isang representative per level. So hindi naman natin kailangan kuhain yung total per level like sa time complexity. Because yung stack natin only contains yung isang path. So pag natapos na kasi yung dulo ng isang path, bumabalik na siya ulit sa gitna. So hindi lumalaki lalo yung program stack na capacity na kailangan natin. Then ayun, ang last part lang dito, yun nga, ang recursion natin gumagamit siya ng additional space. Pero yung additional space na to is from the program stack. And because of how it works, you can often use that to our advantage by applying or when we want to use backtracking or parang kung gusto natin nag-undo yung huli nating action para palitan siya at makakuha ng iba pang result. So, your final activity then to cap off the week is a coding exercise on HackerRank, which is, ayun, I guess pwede ko siyang i-introduce ang dali dito sa aking video. So it's entitled Hexac Payments Only because you find yourself in a weird grocery store where the price tags only contain hexadecimal numbers. And then it turns out yung price ng ating item na binibili is determined by how many other items have the same sum of digits. So for example, yung nasa tag is OX8F. There are 7 other hexadecimal numbers with the same total. So si 9E, si AD, BC, si BDA, E9, at saka si F8. So since there are 7 others with the same total with OX8F, yung price ng item is 7 pesos. And since weird nga yung grocery, Hindi ka pwedeng magbayad ng masyadong konti kasi makukulong ka. And hindi ka rin pwedeng magbayad ng sobra-sobra kasi hindi ka daw nila bibigyan ng supply. So we are forced to come up with a way to calculate the price of an item given yung kanyang hexadecimal tag. So yung input natin is just one line, yung hexadecimal number on the tag of the item. And it's always preceded by 0x to indicate na hexadecimal yung format siya. So kung ano ito, input 2x8. So isang line lang siya. And then yun, ang letter digits natin, yung A, B, C, D, E, F are always given as capital letters. Yung constraint natin dito, you only need to consider hexadecimal numbers with the same number of digits as the one given in the tag. So, and then it is also assumed that this also means na pagka 5 digits yung nasa tag, consider lang natin na other hexadecimal numbers, yung mga 5-digit hexadecimal numbers din when getting your price. So, and then may limit yung digits natin, 1 to 10, kasi mabilis dumami or lumaki yung runtime pagka ganito. Kasi pagka umabot tayo ng 11, we have 16 to the 11 different hexadecimal numbers to consider. Then, ayun, additional zeros at the start of the digits are included in sa count. So, COX000, apat na 0 at saka 0001 are both considered 4-digit na hexadecimal numbers. And then, because of HackerRank limitations and as an exercise din, kailangan yung program nyo is matapos in less than 10 seconds kasi yun yung limit ni HackerRank. So yung output nyo is just a single line containing the price of the item without symbols or currency. So pag nag-input ako ng OX8F, ang ating output ay 7. Since meron 7 other hexadecimal numbers with the same total. And then, for example, ang input natin is 0x0121. Our sample output is 34 kasi there are 34 other 4-digit hexadecimal numbers with the same total. So, naka-enumerate sila dyan. So, ayun. Good luck. So, if gusto nyo ng ayun, so madalas kang magkakaroon ng termination error dito if gumamit ka ng straightforward na code. However, if you do it correctly or in the best way, kaya mong masolve lahat ng cases within less than a tenth of a second dapat. So, yun. So, this one is actually, ayun, dinaanan since dinaanan ng lahat ng 16 to the n digits, magro-runtime error ka sa case 2 pala and the other cases. So in this case, hindi siya makakonsider na. So, good luck with this and I hope you have fun.